Why choose a tandem quad compressor configuration? 1. A tandem configuration reduces operating costs through greater capacity control and lower power consumption. 2. The sequence of operation of the compressors allows the system capacity to be matched to the system load. 3. An individual compressor can be shut down while another compressor continues to run, delivering full capacity and efficiency. Oil management of systems with Crowden Tandem 1 compressors. Tandem compressor systems present certain design challenges: oil compensation, proper oil return, and piping configuration. 2. An oil equalization system designed for correct performance and reliability and the entire operating environment as required. 3. An interconnecting tube at the bottom of the compressor below the oil level ensures oil balance. 4. Small differences in crankcase pressure can result in a significantly fluctuating oil level. 5. The oil separator is installed in the discharge tube of the compression system. 6. The oil separator should separate 95% of the mixed oil in the discharge gas and return the oil back to the low pressure side of the AIB compressor. 7. When the compressors stop, excess lubricating oil in one compressor can flow to another compressor through the oil makeup tube. 8. It is recommended to install a check valve in the discharge pipe of each compressor, which ensures that the refrigerant does not return when one of the compressors is running. 9. Tandem compressors can perform oil equalization when one or both compressors are running. 10. To avoid hot gas bypass from high pressure side to low pressure side, it is necessary to install an oil return capillary in the oil return pipe. 11. A filter is installed before the capillary to prevent blockage. Oil return to the common suction of two Crowley compressors. 1. Oil separator. 2. Non-return valve. 3. Oil filter. 4. Oil equalizer line. 5. Suction line. 6. Discharge line. 7. Oil return line. System characteristics. 1. This solution consists of two compressors that share a common oil separator. 2. The oil that comes out of the separator is fed back into the common lift line of the compressors. 3. It is then fed back to each compressor together with the refrigerant gas. 4. To get a good oil level balance between two compressors, the oil return must be divided equally between the running compressors. 5. The state of the oil could be as dew or as drops along the length and curvature of the pipe. 6. Since the oil returns with the suction gas, equalizing the flow rate of the refrigerant is critical and the velocity of the gas in the suction line is very important. 7. The main riser line that goes from the evaporator to the compressors is connected to a riser head, where the pressures can be equalized. 8. When only one compressor is running, the oil level of both compressors is within the glass. 9. The oil level of a running compressor is higher than the standby compressor. This is due to a lower pressure inside the running compressor. 10. When both compressors are running, the oil level is high and the pressure is balanced, and consequently the oil balance is good. 11. The cost is relatively low. 12. This configuration places a strict requirement on the selection of the size of the equalizing oil line and design of the suction head. 13. The oil separator must be efficient for both single compressor operation and two compressors working together. 14. Requires strict suction piping design. Oil return to a single scroll compressor. 1. Oil separator. 2. Non-return valve. 3. Oil filter. 4. Oil equalizer line. 5. Suction line. 6. Discharge line. 7. Oil return line with system characteristics. 1. The oil that leaves the separator is returned to the crankcase of a compressor. 2. Then, through the oil equalizing tube, it is sent to the interior of the other compressor. 3. When only one compressor is running, the oil level of both compressors is within measurement. 4. The oil level of the running compressor is not as stable. 5. When both compressors are running, the oil level is visible and safe in both compressors. 6. The cost is relatively low, however, oil return requires an additional port in the compressor crankcase. This leads to the introduction of another multi-application compressor model. Single oil return 1. Oil separator 2. Non-return valve 3. Oil filter 4. Oil equalizer line 5. Suction line 6. Discharge line 7. Oil return line with capillary tube system features 1. Each compressor has its own oil separator 2. The oil separated in the oil separator is returned to the corresponding compressor. 3. The oil balance line is installed to prevent one compressor oil level from being much higher than the other. 4. One more sight glass is installed on each compressor to observe the oil level inside each one. 5. When only one compressor is running, the oil level of both compressors is within measure and the oil level of the running compressor is higher than that of the standby compressor, due to lower pressure in the running compressor. 6. When both compressors are running, the oil level is high under all conditions. 7. The design of symmetrical suction pipes is not so strict. Oil return depends on the efficiency of the operating system, not the flow of suction gas. The efficiency of the oil separator only needs to meet the running condition of a single car.